So after having explained the working procedure for vertical ordinates, we pick up one question from past MMD papers where vertical ordinates are given and we have to find center of pressure and thrust on the bulkhead. So the question says a deep tank bulkhead 12 meter broad has the following equally spaced vertical ordinates 3, 5.8, 7.5, 5.8 and 3 meters. The tank contains salt water to a sounding of 10 meters. Calculate thrust on the bulkhead and COP with respect to top of the bulkhead. So what is to be noted here is that the sounding of the tank is 10 meters. And if you just look at the drawing of this bulkhead, it is the top of the bulkhead, 12 meters broad, and it's divided at equal intervals by these vertical ordinates 3, 5.8, 7.5, 5.8 and 3. You can see that the maximum length of this vertical ordinate is 7.5 meter, which seems to be the height of this bulkhead. Okay, and 7.5 is the middle ordinate and it's the longest ordinate. The others are 5.8 on each side, 3 and 5.8 on each side. So the height of this bulkhead is 7.5 meter looking at the ordinates, but the sounding given is 10 meters. So obviously there is 2.5 meter of water above the tank top level in the sounding pipe. And there are 1, 2, 3, 4, 5 vertical ordinates. The bulkhead has been divided into 4 equally spaced segments. So 1, 2, 3, 4 segments equally spaced by interval of h. So what will be the h here? H will be the breadth of the bulkhead 12 meter upon 4 equal to 3 meters. So h is 3 meters. Now we make the table for application of Simpson's rules. First we write down y. Y is the ordinate. Vertical ordinate, the symbol for the vertical ordinates is y coordinate, and we write the ordinates 3, 5.8, 7.5, 5.8 and 3. Simpson's multiplier, because these are 5 ordinates, so 1, 4, 2, 4, 1. So the ordinate is multiplied by the Simpson's multiplier to get area function. Okay, each ordinate is multiplied by the Simpson's multiplier, and we get the respective area functions, product of the area. We add up all these area functions and we get the total sum. 67.4 is the sum of these products. Okay, now as I explained in my previous video on the working procedure with vertical ordinates, area function is multiplied by the ordinate itself again. So we write all the ordinates again, 3, 5.8, 7.5, 5.8, 3 again, because area function will be multiplied by the ordinate and we'll get the y square function. Y square function is the first moment of area. So the area function is multiplied by the y ordinate again, all the area functions, and we get the y square function. We add up and we get sum of the product 399.62. Then the y square function, which is the moment of area, is again multiplied by the ordinate itself. So same ordinates are repeated here, and the y square function multiplied by y ordinate, and we get the y cube function, which is the y cube function is the moment of inertia, second moment of area or moment of inertia function. because y square into y will become y cube. And as I have done in my previous video on the derivation, it's explained that how the y cube function is calculated to get moment of inertia. So now y square function you multiply again by the vertical ordinates and you get y cube functions, and we add them. The sum of the product for the y cube function is 2458.646. To find the area by Simpson's rule, h upon 3 multiplied by sum of the products. H we calculated was 3 meters, so 3 upon 3, and sum of the product for the area function is 67.4, and this gives 67.4 meters square. Now, first moment of area about tank top. Remember, it's all about tank top, not about water surface at the moment. Everything is about tank top. So, first moment of area is a y square function, which is the sum of the product is 399.62. It is a y square function. So, h by 3 into sum of the product of the y square function divided by 2, which I explained in my previous video. Why are we dividing by 2? You can watch the previous video and it's explained why the sum of the product is divided by 2, and we get the first moment of area 199.81 meter cube. Then the second moment of area y cube function, which is the moment of inertia about tank top, tt. Again h by 3 multiply by sum of the product of the y cube function, and this is divided by 3. So 2458.646 upon 3, and we get 819.549 meter raised to the power 4. That is a moment of inertia about tank top. Now, to find the depth of the centroid below tank top, geometric center or the centroid below tank top, we divide the first moment of area with the total area. So, first moment of area we found 199.81 and total area 67.4. Here, first moment of area is 199.81 and total area is 67.4. So, moment of area divided by total area will give the depth of the centroid. Again, below tank top. So, I get 2.964 is the depth of centroid below tank top. Now, we have to apply theorem of parallel axis 2 times. First, we will get moment of inertia about axis passing through centroid, and then we will apply the theorem again, and we will get moment of inertia passing through about the axis which is passing through centroid, because that is IWS is needed for finding the center of pressure. So what will be the moment of inertia about the axis passing through the centroid, which is IgG? So moment of inertia about tank top minus AD squared. So remember that if you have to find moment of inertia about tank top, usually we add AD squared to the IgG, which is a moment of inertia about centroid. So just reshuffling the equation, and IgG will be ITT minus AD squared. So moment of inertia about tank top is 819.549, which we found here by Simpson's rule, minus area of the bulkhead, which is immersed area 67.4, into D square. So D is the depth of the centroid below tank top, because the two axes in consideration here are, one is the axis passing through the centroid, and the second axis is at the tank top level. So the distance between the two axes is the depth of the centroid below tank top. So depth of the centroid below tank top has been found 2.964 here. Yeah. So use this D here, 2.964 squared, and we will get IgG, which is moment of inertia about the centroid, 227.4. Now, knowing the moment of inertia about the axis passing through centroid, I can find the moment of inertia about water surface, IWS, which will be IgG plus AD squared. So IgG, the centroidal axis moment of inertia is 227.42 here, plus area of the bulkhead immersed is 67.4. And now this D is the depth of the centroid from water surface, because the two axes in consideration are, one axis is passing through the centroid, which is giving moment of inertia about centroid IgG, and the second axis is at the water surface level. So the distance between the two axes is the depth of the centroid of the bulkhead below water surface. We found the depth of the centroid below tank top, that's 2.964, and the water surface is another 2.5 meter above the tank top. As we saw before, the sounding is 10 meters. So this D will be 2.964 plus 2.5, 5.464. This will be the depth of the centroid below water surface. And I get the moment of inertia about the water surface, 2239.667 meters to the power 4. Center of pressure below water surface, because moment of inertia being used in the formula is about water surface. So center of pressure, the depth of center of pressure also will be found below water surface. So IWS upon AD. So IWS is 2239.667 divided by area 67.4, and D is the depth of the centroid below water surface, 5.464, as we found it. This gives me depth of center of pressure below water surface 6.079, but the question is asking depth below tank top. So the depth below water surface is 6.079, and there is 2.5 meter of head above tank tops. If I subtract that, I'll get the depth of the center of pressure below top of the tank, 3.579. Thrust on the bulkhead is the pressure intensity at centroid multiplied by area of the bulkhead immersed. So what is pressure intensity at centroid? Density of the fluid, which is salt water, 1.025, multiplied by the depth of the centroid of the bulkhead from water surface, which is 5.464. Total area 67.4. Multiply all the three values and we get 377.48 tons, which is the total thrust on the bulkhead. So if you have watched my previous video where I did explain about vertical ordinates procedure, this would be now very clear that how we proceed with questions where vertical ordinates are given. Okay. So remember, this table will be prepared like this. First we write the vertical ordinates y and Simpson's multiplier. You get the area function, and area function multiplied by the ordinate again. We get the moment of area function, which is y square function, is first moment of area, and then first moment of area function is multiplied by the ordinate again, the same ordinate, and we get the y cube function, which is the moment of inertia about tan top, because this y ordinate, that we are taking the length of the ordinate from tan top downwards. That's why the moment of inertia found will be about tan top. And don't forget that the y square sum, which must be divided by 2. The moment of area function must be divided by 2 when we are using the formula, and the y cube function, the SOP, must be divided by 3 later on while we are finding the moment of inertia. SOP must be divided by 3. Okay, thank you very much, and I will be putting some more videos, one video more, and that will be because I noticed that there is a question in MMD past papers where composite surface has been given, like combination of a rectangle and a triangle. Bulkhead is comprising of a rectangle and a triangle. So I have one more video which will be coming up now. Right, thank you very much.